Okay guys, we're going to move on from Pythagoras to trigonometry. With the application of this, it's still right angled triangles. Okay, so we've got a right angled triangle here. This is still your hypotenuse. Okay, and I'm going to call this H. But in this case with trigonometry, and we're taking a step away from Pythagoras, we're going to relabel our right angled triangle to, I guess, three different sides. And then there was, I guess, previously we haven't really utilized angles. And so there's this Greek symbol called theta. And basically, that is the other symbol for the angle. Okay, it's kind of like a cursive O. Now, the other two sides, we're familiar with hypotenuse, so that makes sense. It's always the diagonal, always the longest side. The other two sides do matter because it's all relative to where theta is. Okay, and in this case, this side that's the vertical at this point in time, it's called the opposite, and we're going to label it O for opposite, because this side here is opposite of theta. Okay, so this side at the bottom, we're going to call it the adjacent. Oops. And we're going to label this as A. Okay, the word adjacent means next to, and we can see that this side is next to theta. Okay, so we've got theta, we've got the hypotenuse, we've got the opposite, and we've got the adjacent. Now, the aim of trigonometry with right angled triangles is to do the same thing, to solve for unknown side lengths, and also, in this case, unknown angles. Okay, so in this case here, we know that this is always going to be a right angle, this is always going to be 90 degrees, but based on the other pieces of information, we don't know what the angles are, we may not know what the sides are. Remember, a really handy tip with trigonometry, with triangles, you need two pieces of information to work out a third. And with Pythagoras, it's always been two sides to work out a third side. But with trigonometry, we're going to be incorporating angles. You might have one side and one angle, and you need to work out a third piece of information given what you've been provided. Okay. Now, this is a famous saying, Sokotoa, and this is just a structure, a set of formulas that I want you to commit to memory and to be really familiar with. And at this point in time, it may not make any sense to you. I might put it on the other side. Sokotoa. And we have a calculator, so which requires you to, I guess, be familiar with three extra functions. We've got a sine function, we have a cosine function, and we have a tan function. Okay, so looking at this calculator here, we can see that we have a button sine, we have another button cosine, and we have another button tan. Okay, and we're going to be using these functions quite frequently, quite regularly during this chapter, based on trigonometry. Okay, so what I want you to write down is that sine of theta is, I might expand this just to get some more space. So sine of theta is equal to the opposite divided by the hypotenuse. Okay, cosine of theta is equal to the adjacent divided by the hypotenuse. And then lastly, tan of theta is equal to the opposite divided by the adjacent. So there's 3 extra formulas that I want you to be familiar with. And the acronym SOHCAHTOA is there to help you understand which ratios we're working with. Okay, so if you're going to be using the sine function, you need opposite and hypotenuse. If you're using the cosine function, you need to use adjacent and hypotenuse. And if we're using the tan function, we need to work out or utilize the opposite and the adjacent. So I need you to have this written in your books so you have something to refer to. If you've memorized it, fantastic. But at this point in stage, you need to have it by your side so you don't make any mistakes. Alrighty. So I want to work out some unknown sides given that we have some other pieces of information. And I'm going to move on to another page to make this work. Okay, so first triangle has a hypotenuse of 17. We have a side of x, and we have an angle of 50 degrees. Okay, and in this case, this is theta. This is your hypotenuse. And this side, this vertical side of x, where it's positioned is opposite the theta. Okay, so then this has to be the opposite. All right. Okay, so now because we're working with the 2 sides that we have is the opposite and the hypotenuse, we need to choose sine. So if we look back at let's try this one. Is it going to work for us? There we go. Okay. If we wanted to work out with our opposite and the hypotenuse, because they are the 2 pieces of information that we have, we need to use the sine function. Okay. We can't use the other 2 because the other 2 don't meet the criteria. Okay, so we're back to this. We know we've got the opposite and the hypotenuse, and we've established that we need the sine function. Okay, so sine, and I'm going to write the formula here. So we are working out what x is equal to, all right? And we're going to substitute all of the pieces of information that we have here into this formula. So sine of 50, because that is what theta is equal to the opposite, which is what we have as x, divided by the hypotenuse, which is 17. Okay? And when we look at this, again, looking at going back to algebra, going back to linear equations, we want to have x on its own. To get rid of the 17, we need to multiply both sides by 17. So multiply this side by 17, multiply this by 17. And so we'll have sine of 50 multiplied by 17 is going to equal to x. So we're going to get our calculator out, and in this case, got my graphics calculator out instead of the scientific one. The other emulator wasn't working, so we're going to work with this for the moment. So you will select the sine button, okay, populate it with 50, make sure you close the brackets, okay, and then multiply by 17 and hit equals. So what we have here is we should change that into decimal, which is 13. Oops. Let's go back. So 13.02 as our side. Okay. Now let's move on to another question and find one where we can work out another side and we'll also work out another angle. Okay. So let's work with this one. So we got this triangle and theta is 31 degrees. We have this side as Z and we have this side as 46. We want to know what the vertical is, but notice that this one, Z is our opposite because it is opposite of the theta, and this is our adjacent because it is next to theta. Okay, so we're no longer using the hypotenuse, and the function that we'll need to use is tan. Okay, tan of theta is equal to the opposite over the adjacent. So going back to the formula, all I want you to do is write it out, and we're going to substitute the values that we have into this formula. So tan of 31 is equal to Z over 46. And 46 is at the bottom. We want Z on its own. So we're going to multiply both sides by 46. And we'll have tan of 31 multiplied by 46. And then we can get our calculator out and start typing away. So tan of 31, let's close our brackets, multiplied by 46 is going to equal, let's get this into decimal form, 27.64, okay, as the side. Alrighty, let's do one more, and in this case we'll do something a little bit simpler where we have this triangle, and let's say we want to work out the hypotenuse. We don't know what that is. We'll make this one as 47 degrees and we'll make A. Okay, so we'll make this, let's pick out a number, let's call it 12. So we want to work out what this triangle is. We want to work out the hypotenuse, and we have the hypotenuse here. Let's call this X, okay? But we are labeling it as the hypotenuse. We know 12 is the adjacent because it is next to the angle theta, and based on SOHCAHTOA, we have the adjacent and the hypotenuse, so that means we need to work with cosine. Cosine of theta is equal to the adjacent over the hypotenuse, and we're going to substitute the values into this formula. Cosine of 47 is equal to the adjacent, which is 12, over the hypotenuse, which is X. The difference with this case is that X is at the bottom, and so sure, you can multiply both sides by X, but that's not going to really get you anywhere. Well, we could try that, but I want to kind of take you to the side here and give you this scenario, okay? And this all comes down to your, I guess, your familiarity with algebra, shuffling things around, and balancing algebraic equations, okay? So if we were to multiply both sides by C, we can say that A times C is equal to B. Yep. And then also from here, if we were to make C on its own, and so we divide both sides by A, we can say that C is equal to B divided by A. Now, if you look at that first equation and compare it to this equation, you'll notice that the difference is that A and C have been switched around. So the point that I'm wanting to make here, to get X on its own, there's a shortcut, and that's basically to swap these two terms around. So X is going to equal 12 divided by cosine of 47. So that's the shortcut. We can introduce the longer way if you wish, and that's completely fine. And that is to multiply both sides by x. So you have x is x times cosine of 47 is equal to 12. And remember, we need to get x on its own, so we'll divide both sides by cosine of 47. So x is equal to 12 divided by cosine of 47. Okay, it's the same thing. I'm just saving you an extra step. The shortcut is to swap these two parts around. So let's get our calculator, and we'll have 12 divided by cosine of 47 close brackets equals, and I'll get that into decimal. Our side is equal to 17.6. So we'll go 17.6 as our side. Okay, so what we've done here is 3 examples of working out the side, an unknown side of a right angle triangle using trigonometry, sine, cosine, and tan function based on knowing one side and an angle. Okay, hopefully that helps you guys. Got any questions, let me know. Otherwise, I'll see you in the next one.